In most places you look in science, you'll see either two things: a linear process with a clearly defined start and end, or a cyclical process with no clearly defined start or finish. The rock cycle is one such cycle. It describes and explains how rock types transform from one type into another. There are three broad categories of rock: igneous, metamorphic and sedimentary. Scientists, being the imaginative bunch that they are, chose descriptive names for these rock types. Igneous, from the same root word as ignite and ignition, are rocks that were formed when molten rock cooled down. Meta, to change, morphic, which means shape, are rocks which are being changed by either heat, pressure or both over long periods of time. And sedimentary rocks are those that are formed from the compaction and cementation of sediments. As with all the concepts in the curriculum, the seeds for the rock cycle are planted during primary school and then drawn together in high school. The rock cycle is no different. Students begin looking at geological changes as early as Year 1, develop further in Years 4 and 6 with a formal introduction of the rock cycle in Year 8. Now, this is in the end, as the theory of plate tectonics, a crucial element of how the rock cycle works, is dealt with in Year 9. I'm hoping you're beginning to get a really good sense of the constructivist and spiralling nature of the Australian curriculum. This is a fun little clip giving the basics of the rock cycle. My challenge to you below is to use this clip as your base and then do a Google search for the rock cycle, which will allow you to achieve the other objectives listed below. You might want to leave the diagram in pencil and have it checked by your tutor in the laboratory. Of course, there are diagrams of the rock cycle everywhere on the internet, so you can check yourself. So your objectives are to diagrammatically represent the rock cycle as a flow diagram, colour code the processes and products of the rock cycle, and annotate the diagram with examples of each rock type. One of the challenges people face when they come into science is that the phenomena that we study are on scales outside everyday common experience. They're either too big, for example the solar system or the universe; they're too small, germs and molecules; too far away, other planets and stars and galaxies; they're too fast, chemical reactions and light; or in the case of the rock cycle, too slow. We evolved on a planet where things in everyday experience occur at a certain pace and under certain laws. So when scientists start talking about millions and billions of years, or quantum mechanics, our poor hominid brain just can't cope with it. Let's talk about the geological time, because this is an important concept for understanding not only the rock cycle, but also other things like cosmology and the age of the universe and evolution. Use a variety of models to get across just how old the universe and or Earth is. Search the internet for things like the clock model of the age of the Earth, or a 100-metre running track as your model. Judge a model by how constructivist it is. Is it using metaphors and analogies that are within the everyday experience of students? Is the representation still accurate? Does it start simple and move on to more complex ideas? Apply this thinking to any explanation you want to use in the classroom. Teaching and learning about rocks can take on many forms, as teachers can focus on one or all of the following themes: our amazing Earth, understanding and exploring rocks, who are rock scientists and what do they do, and my personal favourite, using minerals in everyday life. Students have little understanding of how society is dependent upon these materials: metals, fossil fuels, oil and petrochemicals, plastics and coal. Invite students to think of their daily lives and activities and how these aspects are deeply interconnected. Providing these real connections helps address the alternative conceptions that all rocks are stones and have little importance in students' lives. Some alternative conceptions are: pebbles and stones are thought of as not rocks, all rocks are thought to be hard, rocks stay the same forever, soil must have always been in its present form, and that the Earth is molten except for its crust. To understand the CDSU and how to address these alternative conceptions, please see the written materials for this week. Thank you.